Okay, so let's begin by knowing how to find the nth term of a linear sequence. So in this example we have here, it says find the expression for the nth term of the sequence that starts with 5, 8, 11, and 14. Okay, now looking at this should be a arithmetic progression. It's an arithmetic sequence because when you check the order of this sequence, for instance, the difference between 5 and 8 is 3. Difference between 8 and 11 is 3. Difference between 11 and 14 is also 3. Alright, so this is an arithmetic sequence or progression. Now, for arithmetic sequence, basically this is the formula we use for arithmetic sequence. This is basically the formula. We have it to be a plus n minus 1 d. So this is the formula you are meant to be using to find number of terms. Now, basically for this question, we have to find the expression for the n term. Now that we have known that the common difference, our d, is 3, that means the expression for the n term is going to have 3n in it. Let's begin by bringing out let's begin with this. Now, in this question, we have the number of terms. We have it to be 1, 2, 3, 4. We will have 4 terms in the equations. So we have the terms itself to be 5, 8, 11, and 14. Since our expression for the nth term is going to contain 3n, so this expression 3n will be the value of n. N has various values here. We have when n is 1, the term is 5. When n is 2, the term is 8. When n is 3, the term is 11. When n is 4, the term is 14. Okay, so 3n will be 3 times 1, to give us what? 3. Now, 3n when n is 2 will be 3 times 2, give us what? 6. But this one was when n is 1, 3 times 1 give us 3. Now 3n when n is 3 will give us 3 times 3, which will give us what? 9. 3n when n is 4 will give us what? 3 times 4 give us 12. Okay, now for the term itself, remember trying to get the expression for the n term. Alright, so this is the procedure you take when you have known your common difference. Very, very important, guys. Now, our term itself is still 5, 8, 11, and 14. Okay, so let's take a difference here. The difference here, 5 minus 3 gives us 2. 8 minus 6 gives us 2. 11 minus 9 will give us 2. 14 minus 2 will give us 2. Okay, so with this occurrence, now we can deduce that the expression for the nth term will be 3n plus 2. This will be the expression for the nth term. Now let's check if this expression is correct. When our n is 1, let's see if we're going to get back to these 5, each of these numbers respectively. When our n is 1, let's check it. 3 times 1 is 3 plus 2, which will give us 5. Is correct. When our n is 2, 3 times 2 is 6. 6 plus 2 will give us 8. Correct. When our n is 3, 3 times 3 is 9. 9 plus 2 is 11. Correct. When our n is 4, 3 times 4 is 12. 12 plus 2, 14. Okay, so that shows that this is correct. This expression is what is correct. Now, using this formula, if you're asked to find, let's say, the 5th term or the 6th term, when you break this formula down, you're going to have, if you're asked to find the 5th or 6th term, okay, let's say 6th term. The 6th term will be, in this example, this is our first term, our A. A stands for the first term. So this is the first term in this question, 5. So for the 6th term, C6 will be, this is 6, guys. C6 will be our first term, which is 5 plus, now the number of terms, we are looking for the 6th one. It should be 6 minus 1 times, our common difference is what? 3. When you simplify, it's going to have 5 plus 6 minus 1 give us 5. Our 5 times 3 give us 15. Okay, so that means our C6 will be 5 plus 15 will give us 20. Now let's verify using this expression for the nth term. Okay, now it's 6 times. When you plug in 6 here for n, 3 times will give us 18. 18 plus 2 will give us 20. Alright, so this is correct. This is basically how you can deal with this kind of problem.